He's going to provide us, hopefully, some insights into some of these questions. These are some of the things I'm hoping we can cover during the session. I guess we'll start, Jim Melton. I have to remember now we have two Jims. We'll start with something that you and I have discussed a couple of times in the last year and a half, which is, you know, SQL comes from the era when people thought international standards and formal standards were important. In more recent years now, we've had things like the Java process and XML, and those are not formal international standards. So I guess the question is, for what we're doing over the next decade, are formal standards relevant, international standards?
Well, I certainly believe that standards are relevant. If you're talking about millions of devices, billions of devices communicating with each other, it's imperative that there be standards for that communication. And there be standards for querying the data, for storing the data, for managing it. Whether or not those standards are de jure, whether they're done in the ANSI or ISO process, is a lot less important than whether the standards exist. I think the different standards communities like ANSI and ISO versus the Java community process versus consortia like the W3C all serve very good marketplaces, very good services are provided by these different fora. And we're beginning to learn to work together, in fact. ANSI and ISO have formal relationships as liaison with W3C and vice versa. The SQL XML work that you referred to earlier, the SQLX group, is deliberately working with both sides of this debate, both sides of the question, so that we work with the formal groups on one side, consortia and de facto groups on the other side. The point is, we're getting standards in place.
And hopefully, at least we'll be continuing to adopt them in the future as we have in the past.
I sure hope so. Quick thing I'd like to add to that, the de jure process has been rightfully criticized as working on geologic time rather than internet time. And I think they're finally waking up to this fact and beginning to put into place policies and procedures that allow things to be progressed much more rapidly, such as fast-track processes by which independent groups can put together a spec, toss it into the de jure forum, and have an immediate ballot to decide whether it actually is good enough.
Jim, great, the other Jim. Actually, we should, all have nicknames, like number one, number two. But anyway,
Sailor.
I think you and I have talked about this before too. One of the other issues, obviously, that we face is that now with widespread computing around the world in organizations that are widely distributed, and a desire to use the internet as sort of the backbone or the infrastructure for doing transaction processing, what's the scenario that we face over the next few years? Will we be able to do, let's say, reasonable transaction processing when you're talking about maybe having 500,000 to 1 million people that want to connect to a database? Like if there's some sort of, I think I've told the story before about being in the UK where they did this broadcast to everybody that was in a shopping center, and the athletic shoe store had 2 people. They did the broadcast, and within like 3 minutes they had 75 people because they offered free shoes to the first 10 people who came in. So we'll probably be doing these sort of massive web services with 500 million to 1 billion to 1 billion people connecting. How do you do transaction processing in that sort of scenario?
What to say? You can go and visit Google. A lot of people visit Google in a day. You can go and visit Hotmail. The way these systems work is that they have on the order of 10,000 processors sitting in front of them, making all the eye candy. And the application itself is, in the case of Hotmail, beautifully partitionable because you could have 1 computer per mailbox. And in the case of Google, it's a decision support kind of application which allows for replication so that you can divide the work up among as many replicas as you want. So you have to think about what application it is you want to have. The TPC benchmarks, which we all have lived and died by through the 1980s and into the 1990s have now become kind of, well, I'm not sure the word irrelevant is the right word, but the fact is that we've got things where people are doing well over 1 billion transactions a day. And there's no financial institution that does 1 billion transactions a day. There's in TPC, you've got this thing where you've got, what, 10,000 warehouses or something like that? Not very many people, not very many companies have 10,000 warehouses. On the order of 1 million clerks. So I think for the traditional applications that we set out to do, we set out to do many years ago 1,000 transactions a second, and that seemed like a lot because it was 10 times what we could do at the time. That is now something you can do with that little server you bought. The embarrassing thing at this point is that the cost of a computer is not the cost of the hardware. It's not the cost of the software. It's the cost of the management. That machine, again, you bought is $8,000 to $10,000 a year in care and feeding, and that's actually the dominant cost. So I think for the real challenge that we face is to make computers self-managing so that management cost comes down to be less than the capital cost.
Thank you. Don, you've been instrumental in developing query languages for a number of years now. Obviously, XQuery is more document-centric than SQL was. And so I guess, one of the questions, obviously, that people are going to have over the next few years is, what can we really expect in terms of being able to find information in documents? You might want to elaborate on that a little bit.
Okay. This is a pretty exciting time to be in the database industry. Designing new query languages is lots of fun, and I've taken care to time my career so that I got to participate in a couple of those cycles. I think that what database people are trying to do right now is they're trying as hard as they can to catch up with what happened in the 90s. Because in the middle of that decade, all of a sudden, pretty much overnight, all the computers in the world became connected together. And this was kind of like in the early history of the universe, the phase changed when the universe became transparent and you could suddenly, light could travel from one end of it to the other. It was a pretty stupendous event. You can hold a laptop that's about the size of a book, but in fact it's all books. And it's not only all books, but it's all newspapers and all pieces of music and all works of art. In short, you can hold the collected works of mankind on your lap. And so this should be the golden age for database management. But it turns out that not all of the collected works of man look like rows and columns. And rows and columns were what we were real good at processing. We had lots of systems that knew what to do with rows and columns, and they were real good at indexing them and optimizing access to them and logging them and doing recovery on them and all the kinds of things that databases need to do. But now all of a sudden, with the advent of the web, there was lots of data out there that needed to be managed, but it was unstructured or semi-structured. A lot of it was sparse data. A lot of it was order dependent. A lot of it was heterogeneous, and so it needed to be self-describing. A lot of it came from streaming sources like stock tickers and things like that. So I think for the last 8 years about, the database industry has been trying to figure out what are we going to do with all of this data that doesn't look like traditional data. So if you allow me, I'll make a few predictions.
Yeah, go ahead. That's what we're here for.
My first prediction won't shock anybody. I think that XML will become the dominant format for data interchange because XML is a very flexible format and because XML data is self-describing. So if you have data that's sparse and you need it to describe itself so you don't have to carry along a lot of null values for things that don't apply, XML is pretty much an optimal format that's designed around that criterion. And my second prediction, which may be a little bit more controversial, but I believe it, is that many applications will want to query data in the same format that they interchange it. In other words, if my enterprise exchanges data with yours, we'll want to exchange it in XML because that makes the data nice and self-describing. And if we're exchanging data in XML, and I have some question that I want to ask you, I'm probably going to want to ask the question in the same format that the data is exchanged in. In other words, I view you as a source of XML data. Now, I don't know what's happening behind the curtain. Maybe you're storing your data in a relational database or an object-oriented database or under your bed. I don't know where you're storing it. But as far as I'm concerned, it looks like XML. And I think I want to write queries against an XML source. And that's the reason that we're trying to develop in W3C a new query language called XQuery that's based around XML. My third prediction is that relational databases won't go away. SQL won't go away. Relations are a very good way of storing data that's homogeneous and repetitive and looks like rows and columns. Lots of data looks like that. Data independence is an important property of relational databases, and it's as important now as it ever used to be. So I think instead of going away, what relational databases will do is grow front ends so they can export their data in XML format to people that want to look at it that way. And they can process XQueries, XML-based queries against that data by translating it into relational format. I also predict that other kinds of data sources will do the same thing. They'll grow XML front ends and translators to process languages like XQuery as well. So I think we'll have a variety of data storage systems that store data in many different ways and export the data and process queries in XML format as a kind of a lingua franca that allows data in different formats to be exchanged. And so we'll have digital libraries and object-oriented databases, and we'll have native XML databases, we'll have relational databases, we'll have streaming data sources, and XML will kind of be the common interchange among all those different kinds of sources. And I think one thing that we'll see happening is that some of our large relational systems will adapt to XML as a native format, make XML a first-class citizen, if you like, a interface that's supported with equal precedence to the relational interfaces that they've traditionally supported.
To raise a level of abstraction for a second, if we're talking about doing document-centric processing, you obviously believe that XML is going to be the key technology for querying documents. Do you see that we'll be sort of following the progression that we've had in the past where you start with a language and then people start building tools that use the language as the infrastructure so that you end up with like point-and-click queries, that sort of thing?
Yes, I do. I think that we're in the early days with this language development work. There's lots of work still to be done. We haven't seriously addressed the issue of update yet in the XQuery working group. We haven't seriously addressed issues of transaction processing. We need to do a lot of implementation work on how to index XML data and how to build the robust infrastructure around the XML format that relational systems have had for many years.